Let's look at a few redox reactions and assign oxidizing and reducing agents. So this is a famous reaction, the rusting of iron. So here I have some iron metal, and we add some oxygen gas to it, and we form iron 3 oxide as our product. So let's assign some oxidation states. So let's ignore the coefficients, right? The coefficients are for balancing chemical reactions. So let's just think about those iron atoms as atoms being in their elemental state, and so therefore we know the oxidation state of those atoms is equal to 0. I move over here to oxygen gas and ignore my coefficient and think about the oxygen atoms in the O2 molecule. Right? Those atoms are in their elemental state, and so therefore they have an oxidation state or an oxidation number equal to 0. I move over here to my product, ignore my coefficient. I know that for compounds like this, oxygen usually has an oxidation state equal to -2. So I put a -2 here, and I like to circle these just to distinguish them from all the other numbers on the screen. And I have 3 oxygens. Each one has an oxidation state of -2. So -2 times 3 gives me a total of -6 for all of my oxygens. I know for a neutral compound, the sum of all my oxidation states has to add up to equal to 0, and so therefore I know the sum of all my irons has to be +6, since +6 and -6 would give me 0 here. Since I have 2 irons, each one must be +3, and so now I've assigned all of my oxidation states for this redox reaction. Let's think about what's happening to the atoms here. So if I think about an iron atom going from an oxidation state of 0 to an oxidation state of +3. That's an increase in the oxidation state, right? And we know by definition an increase in the oxidation state means oxidation. So we can go ahead and say that iron is oxidized here. And we know if iron is oxidized, it's losing electrons, right? So loss of electrons is oxidation. In this video, we're not so concerned with how many electrons iron is losing. We'll worry about that in balancing redox reactions. So for right now, we just know that iron is oxidized and it is losing electrons in this reaction. Oxygen, let's look at the oxidation states. It's going from an oxidation state of 0 to an oxidation state of -2. That's a decrease in the oxidation state. A decrease or a reduction in the oxidation state is, of course, the process of reduction. So oxygen is being reduced here. And so we know that when something is being reduced, it's gaining electrons. Leo the lion goes grr. So gain of electrons is reduction, like that. Now, once again, for this video, we're not concerned with the exact number of electrons, but we know that the electrons that iron loses are the same electrons that oxygen gains. And so that number is actually the exact same. So iron, by losing electrons, is allowing oxygen to be reduced. And so therefore you can say that iron is the agent for the reduction of oxygen. And so we're going to say that iron is the reducing agent here. So iron is the reducing agent. All right, thinking about it the other way, right? So if you think about oxygen, right? Oxygen is gaining electrons from iron. So oxygen is allowing iron to be oxidized. So oxygen is the agent for the oxidation of iron. And so therefore oxygen is the oxidizing agent. So I'll go ahead and write oxidizing agent here. And so this can be confusing to students because if you think about it, right, it makes sense that iron's being oxidized here, but then you change it and you say, oh, it's the reducing agent. It's not really changing anything. It's just the definition of your reducing agent. Your reducing agent itself is being oxidized, and it's allowing something else to be reduced. And so if you think about it here for oxygen, right, so those oxygen atoms have a decrease in their oxidation state. They are being reduced, but by the fact that they are being reduced, they allow something else to be oxidized. So they are the agent for the oxidation of something else. So you could say that O2 is your oxidizing agent. So let's go ahead and look at this little table here where I've summarized this for you. So we have reducing agents and oxidizing agents, right? So we'll stick with the same colors that we've been using here. So a reducing agent, right, is the agent for the reduction of something else, but it itself is being oxidized, and so therefore it's losing an electron or many electrons, right? So common reducing agents would be things that lose electrons easily, so things like metals. All right, if I think about oxidizing agents, right, so oxidizing agents over here, so the agent for the oxidation of something else, therefore it itself must be being reduced. And if something is being reduced, it's gaining an electron or gaining many electrons, right? So something that would gain electrons, you could think about very reactive nonmetals. So things like oxygen that we talked about in the previous example. So let's do one more, and let's see if we can figure out the oxidizing agent and reducing agent for this reaction. So once again, we'll ignore our coefficients. We think about our rules for oxidation states. We know that for a monatomic ion, the oxidation state is equal to the charge on that ion. And since the charge is 2+, we know the oxidation state is 2+, or +2. Right? I think about chlorine. I think about the atoms in the chlorine molecule. Those atoms are in their elemental state. And so we know an atom in its elemental state has an oxidation state equal to 0. I move over here to iron 3+, ignore my coefficient. A monatomic ion has an oxidation state equal to the charge on that ion, so the oxidation state is +3 here. And I think about the chloride anion. I ignore the 2. I think about the negative charge, right? A -1 charge, meaning the oxidation state is -1. So when we look at what happened in this redox reaction, right, we know that we went from an oxidation state of 2+ to an oxidation state of 3+. That's an increase in the oxidation state. Right, so we know an increase in the oxidation state means that iron 2+ was oxidized in this reaction. So iron 2+, let me go ahead and use these colors here. So iron 2+ was oxidized. All right, let's look at chlorine now. So a chlorine atom went from an oxidation state of 0 to an oxidation state of -1. That's a decrease in the oxidation state. A decrease in the oxidation state is reduction. So we can say that chlorine was reduced. All right, so let's now think about oxidizing and reducing agents. So iron 2+ was oxidized, right? And the fact that it was oxidized, right? It's losing electron, right? So it is itself being oxidized, but it's causing the reduction of something else. So it is our reducing agent. So iron 2+ is being oxidized, but it is our reducing agent. And when we think about chlorine, right, chlorine is being reduced, the chlorine atoms are being reduced, but in so doing, right, they cause the oxidation of the iron 2+. And so therefore we can say that chlorine is our oxidizing agent. And so that's how to think about redox reactions. If your oxidation states change, you can consider it to be a redox reaction. And then once you look at those oxidation states, you can figure out what is oxidized and what is reduced. And you can also figure out which one is your oxidizing agent and which one is your reducing agent.